And now that we know about physical weathering, which is again just breaking apart a rock without changing its chemical composition, now we can talk about chemical weathering. And this is when the chemical composition of the rock does change, right? The elements inside it, the bonds inside it do change to create a new material, right? So chemical reactions alter the rock's composition. And there are three types of chemical weathering we're going to talk about: dissolution, hydrolysis, and oxidation. And all of these are aided by carbonic acid. So carbonic acid, it's something that naturally occurs when carbon dioxide, which is present in the atmosphere, is introduced to water, which is all around us, right? So this process is naturally happening all around us all the time. So when carbon dioxide goes into water, it produces carbonic acid. This is one of the reasons why soda is so bad for our teeth, because of that carbon dioxide within our drinks. It produces that acid. And the production rate of carbonic acid increases with warmer temperatures. Right? That's going to be important a little bit. All right, so dissolution, the first of the three chemical weathering processes we're going to talk about. Dissolution occurs when rocks are in the presence of water. So water molecules, H2O, they're polar, and that just means that there is a slightly positive charge on the hydrogen and a slightly negative charge on the oxygen. And this polarity is what causes rocks to dissolve. It causes the elements within those rocks to bond to stick to the polar water molecules, and it slowly breaks down rocks over time. So this is dissolution, and this happens more rapidly when there's carbonic acid present. Right? So dissolution is really common in rocks like limestone. This is a major cause of sinkholes. Right? So if you have, as we talked about before, you have carbon dioxide added to water that creates carbonic acid. You introduce carbonic acid to a rock like limestone, and that's going to start dissolving the limestone. And that's going to create sinkholes. That's one of the reasons that sinkholes are so common in places like Florida, where the material, the land is made up of a lot of limestone. And these features, these erosional features due to dissolution, we call that karst, right? So that's like the caves and the sinkholes. So places that are made up of limestone, like Florida, right, so we see the sinkholes on the surface, and those are big and scary, but if you were actually look underneath the surface, there's a lot of empty space that has just been dissolved out, right? A lot of karst, a lot of caves underneath the surface. All right, that's dissolution. Now we're going to talk about hydrolysis. Hydrolysis, once again, it's weathering due to water, but now it's weathering of silicate minerals. So a weak carbonic acid can decompose silicate minerals. Remember, silicate minerals are those that have silica inside of them, which most of them in Earth's crust do. So this is the most common type of chemical weathering, and it consumes carbon dioxide out of the atmosphere. So this is really cool because carbon dioxide is a greenhouse gas. We don't want a lot of it in our atmosphere. So the hydrolysis, this weathering of silicate rocks, actually consumes carbon dioxide, taking it back out of our atmosphere. All right, and as I said, chemical weathering changes the composition of a rock. So an example of that is during hydrolysis, the mineral feldspar will be weathered into clay. All right, and if you look at this chemical reaction here, feldspar combined with carbonic acid produces an entirely new mineral called kaolinite, and also eventually calcite. Kaolinite, by the way, Georgia leads the United States in the mining of kaolinite. It's a huge part of our economy. Alrighty, now we're going to talk about oxidation, and you can think of oxidation just like rusting, right? So oxidation is any time an element loses an electron and combines with oxygen, right? Again, it's just like rust. So an example of this is ferrous iron to ferric iron. This iron 2+ to iron 3+, and when this happens, minerals can rust. So for example, this pyrite crystal, you might have also heard pyrite be referred to as fool's gold. It's a really pretty golden color. and it can rust, which is what you're seeing here. Those red lines around that mineral is that oxidation, the rusting. So anytime you see bright red rocks or bright red clay, there's a good chance that that's because of oxidation and chemical weathering. So you know that rock is weathering, that rock is breaking down if it's that bright red color. Right, chemical weathering can also be biologically driven. Just like we said that biology can physically break up rocks and mechanically break up rocks without changing the chemical composition. Think like meerkats digging in the ground or tree roots pushing open a crack in a rock. Biology can also physically change the chemical composition of a rock. So for example, lichen, moss, ferns, when they grow on top of a rock, they can actually cause chemical reactions that change the chemical composition of the rock.